Aeronautics and Space Report.
Applications Technology Satellite, ATS. That's the name given to this spider-shaped spacecraft, one of the most versatile ever developed. Its purpose? Test out experimental systems for improving weather forecasts, radio, television, and communications of all kinds. Mounted atop the reliable Atlas Agena rocket, the 790-pound satellite was boosted into a stationary orbit, hovering in place some 22,300 miles out from Earth. These pictures, taken between 7:05 a.m. and 10:05 p.m., show the changing cloud pattern over the world for an entire day, giving weathermen their first continuous view of developing storms. Up till now, airplanes flying over mid-ocean have been out of radio range for periods of an hour or more. With ATS technology, airlines may be able to keep in touch at all times. Recently, at NASA's Goddard Space Flight Center, this new system of communicating with aircraft was demonstrated in a series of tests, with the press attending. One of the tests was with an airplane flying just southwest of San Francisco. The communication traveled some 50,000 miles from Goddard to the Mojave Ground Station near Barstow, California, to the satellite, and finally to the airplane.
Live. Go ahead, United 2621. Goddard, clear.
Roger, Goddard, test control. This is United Airlines Flight 2621. Captain Collins speaking. We want to say that your transmissions are coming in loud and clear.
Pan American Flight 6004. This flight is about 3 hours and a half east of Tokyo. Pan American Clipper 6004. This is Goddard test control. Go ahead.
Goddard control. This is the Clipper 6004. How do you read?
ATS can also relay color TV. In another demonstration, color television was relayed from the Mojave facility by satellite to Rosman, North Carolina, and then by conventional means to Goddard.
We have enlarged the picture we received from the spacecraft, and we have our weather girl with that enlargement.
Serving as a telephone switchboard, ATS can handle 600 two-way or 1,200 one-way calls between stations far away from each other. Places like Japan, Australia, and the United States will try to communicate through the satellite. Applications Technology Satellite. During the spacecraft's 3-year lifetime, it will test out new communications concepts, making it truly a switchboard in the sky. Sometime in the future, American astronauts will explore the moon. Then take off from the lunar surface and return to Earth. For the machines which will do the job, a series of intense fabrication and tests. Here, the beginnings of the ascent stage propellant tanks for the lunar module. When completed and installed, they will be used to store and feed tons of liquid fuel to the main engine as it lifts off the moon. Because of the critical role they play in the Apollo mission, their chance of failure must be less than 2 in a million. Made by the Aerojet General Corporation, the tanks are put through 34 major shop operations. The 2 half shells are machined from 1 1/2 inch thick rough forgings down to 35 thousandths of an inch, thinner than a dime. After machining, the tank halves are welded together automatically in a special vacuum chamber. The sphere is then submitted to temperatures up to 950 degrees in an electric furnace to relieve stresses in the metal built up during machining and welding. Samples of titanium alloy, of which the tanks are made, are also heated and later stretched to the breaking point to make sure the tank's physical properties meet specifications. To ensure an instant start of the spacecraft's engine under the moon's zero or low gravity conditions, a special screen is machined to trap small amounts of fuel. 2,300 holes, about the size of a pinhead, are drilled to make the screen. This is a centrifuge. Earlier qualification models of the tank were whirled up to 14 Gs, 14 times the force of gravity, simulating the worst possible conditions the lunar module might encounter on its trip to and from the moon. One of the final steps is a thorough cleaning in an atmosphere-controlled clean room. Contamination levels must be within certain limits. To make sure, residue left over after the cleaning is noted for size and the number of particles actually counted under a microscope. Checks for leaks, vibration tests, these and many more go into the 16 weeks it takes to produce one of these spheres. Fabrication, qualification, testing, reliability, a necessity when second best is not good enough.
Okay, we're going straight up. 10 seconds. We're going to go to our slide. Ready till up. 5, 4, 3, 2, 1. Take it. On up.
Because of the following special one-hour broadcast, programs previously scheduled at this time will not be seen.
30 seconds on it. Stand by to wipe to the bird, and they can live early bird. Wipe. And you're in there. Mexico is on the line. Mexico is feeding the bird. Light X1. Right now, we're on Mexico.
This event, television beamed via satellite, is now commonplace. To make it possible, an experimental program was initiated in 1958 to develop the technology, the capability for communication satellite systems. The advantage of satellite communications is height. Microwave transmitted in a straight line carries telephone, teletype, and TV. But a hill in the path of a microwave tower can block the signal, and the system stopped at the ocean's edge until we had communication satellites. ECHO, NASA's first experimental system, was a passive communication satellite. Passive because it served as a giant mirror, reflecting signals transmitted by one ground station to the receiver of another. Then Telstar and investigations of active communication satellites, called active because they have the ability to receive, amplify, and retransmit signals to distant locations. It was AT&T's Telstar that provided the first live intercontinental television transmission in 1962.
Kiki, la chansonnette après l'épée.
Because Telstar was in sight of ground stations for short periods of time, transmissions were intermittent. Another medium-altitude satellite was NASA's Relay 1 and 2. Thousands of tests and experiments were conducted over Relay, many involving transatlantic and trans-Pacific television transmissions. Next, a high-altitude satellite orbiting at the same relative speed as Earth, appearing to hover at one point at all times. NASA's experimental SYNCOM satellites were the first to be placed in such synchronous orbits. It was via SYNCOM 3 that live television coverage of the Tokyo Olympic Games was accomplished. From experimental to operational, the Communications Satellite Corporation adapted the SYNCOM design concept to the world's first commercial communication satellite, Early Bird 1. With Early Bird and later operational communication satellites, long-distance telephone, telegraph, and television transmissions have become a common occurrence. Here, heart surgery seen thousands of miles away as it was performed. To test even newer communications concepts, NASA is placing in orbit a series of applications technology satellites. They will be used to try out new systems for improving aircraft communication, color television, and many other advanced experiments. Whether spanning continents or oceans, experimental and operational communication satellites are playing an increasingly vital role.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.
It's not easy to put men on the moon. One of the problems is to know just where to land once you get there. A series of picture-taking lunar orbiter spacecraft are helping to solve this problem. the most recent flight, Lunar Orbiter 3, recorded and transmitted pictures of 12 potential landing areas. Much new scientific knowledge has been returned in addition to the lunar landing information as a result of the Orbiter series of pictures. We now know more about the moon's shape and its gravitational field. Meteoroid measurements will help designers of future spacecraft determine if the small, high-speed particles are a hazard. Actual amounts of radiation can also be measured. This series of pictures shows not only a potential landing area for astronauts, but the place where Surveyor 1 landed. The mountain range shown here in a lunar orbiter photograph looked like this to Surveyor on the moon's surface. These are some of the other primary site photos, and one of the hidden side of the moon. Lunar Orbiter, recording views of the moon in greater detail than is possible through earthbound telescopes. Detail needed to help select sites for safe lunar landings. Next month, NASA plans to launch an unmanned Mariner spacecraft to the planet Venus. We know very little about Venus because we cannot see through its thick clouds. The 540-pound Mariner will attempt to shed light on the origin and nature of the planet and its environment, giving us additional knowledge about our solar system. Mariner stands 9.5 feet high and spans 18 feet with its solar panels extended. After being launched, Mariner will fly through space for nearly 3.5 months, traveling some 219 million miles. By mid-October, its trajectory will have taken it to within 2,000 miles of Venus. At this point, the scientific instruments will do their job, sensing, recording, transmitting data about the Venusian atmosphere and ionosphere, reporting on its magnetic fields and the energy levels of cosmic rays and the solar wind. Large tracking antennas of the Deep Space Network will receive the transmitted data and report back to the Mission Control Center at NASA's Jet Propulsion Laboratory in Pasadena. When the flight of Mariner Venus 67 is completed, we should know more about the clouded planet than ever before and better understand the nature of interplanetary space. San Marco. That's the name of a scientific satellite recently sent aloft from this sea-anchored launch pad off the coast of Kenya, Africa. The project, a cooperative effort between NASA and the Italian Commission for Space Research. The primary objectives, report on the makeup of the Earth's atmosphere and investigate the causes of interference with long-range radio transmissions in the region of the ionosphere. The San Marco launch was a highly successful one, and the data resulting from the program will be made available to the world scientific community.
I think as far as walking is concerned, it's clear that a man's going to leave footprints, and there'll be a very accurate record of footprints, perhaps an inch or so deep, of just where he's gone. All he has to do is take a picture looking back, and he'll have a complete record of his travels.
Dr. Eugene Shoemaker, answering questions about the flight and moon landing of Surveyor 3 and what it will be like when men walk there. Surveyor began its descent to the lunar surface 53 hours after liftoff from Cape Kennedy. Bouncing 3 times, it came to rest about halfway down the side of a crater 650 feet across and 50 feet deep. Shown here being tested before flight is Surveyor's surface sampling device. Scientists wanted to see what happens to the chunks of lunar material and how it breaks up. From these tests, we know that the lunar surface is slightly cohesive and behaves much like fine-grained granular soil on Earth. A small quantity of soil was placed on the white footpad of Surveyor. This is what it looked like in color. Color helps geologists tell the difference between various rock types and aids in determining the weathering process. While the Earth was partially illuminated by the sun, Surveyor gave us a look at our own planet. Here, the continents and oceans have been superimposed for reference. These pictures, put together in sequence, show a lunar sunset. Man is going to land on the moon, and he will bring back pieces of it to Earth. Surveyor 3 and those to follow will help make it possible. At NASA's Marshall Space Flight Center in Alabama, 12 astronauts recently began practicing for long-term manned missions into space. These missions will be unique. Unique because it will be the first time a large rocket stage is used, not only as a fuel carrier, but as an orbiting space station for astronauts. The actual rocket looks like this. It serves as the second stage when mated to the uprated Saturn booster. The stage remains in orbit after its initial job is finished. Later, a crew of astronauts meet and join the empty rocket. They will crawl inside the big hydrogen tank and set up living quarters, staying in space from 28 to 56 days or longer. To prepare themselves for missions like these, the 12 astronauts visiting Marshall inspected mock-ups of the orbital workshop and performed a variety of tasks. This is what it looked like inside as the astronauts became familiar with the living working area of the fuel tank. Entire sections of the interior were set up so that the men could practice. Some of the astronauts were strapped into zero-gravity simulators to better understand how it feels to perform while weightless. The orbital workshop is about the size of a 3-bedroom house. When put into operation, the crew will be able to move freely without special clothing or breathing equipment and conduct experiments ranging from Earth resources studies pertaining to the quantities and status of our air, water, minerals, animal, and marine life to solar astronomy observations to learn more about man's role in the long-term exploration of the universe. This picture of the moon's far side was taken by NASA's Lunar Orbiter 5, then transmitted some 250,000 miles through space to Earth. Lunar Orbiter 5 is the last in a series of moon-circling craft. After the pictures are initially received, they are sent to NASA's Langley Research Center in Virginia for screening to help determine possible astronaut landing sites. One device measures variations in density, variations revealing the height and depth of lunar craters. A landing site must include a 3 by 5 mile oval free of major obstructions. Craters in the landing ovals are counted, just one of the methods of rating whether a landing area is good or bad. Early lunar maps showed only the largest features, such as mountain ranges and major craters. Observatory pictures were better, but still left a lot to be desired. This small dot was indistinguishable as a crater on the first map. Lunar orbiter photos clearly revealed the crater to be 1.5 miles in diameter. It is this kind of detail that makes landing site selection a much simpler task. This is the crater Copernicus. Orbiter 2 photographed the same crater from this angle. Here are some other views taken by Lunar Orbiter 5. And an astronaut's view of our own planet as seen from the moon. For them, the astronauts, lunar landings will be much safer. Safer because of the pictures returned by these orbiting explorers. From this point, U.S. manned lunar expeditions will begin. It was here that the first Saturn V moon rocket was recently assembled for flight, inside a 52-story building, a building so immense that nearly an hour is needed just to open one of its doors. But the vehicle assembly building does not stand alone in its hugeness. The Saturn V rocket with an Apollo spacecraft on top is itself 363 feet tall. Someday it will carry 3 men and equipment to the moon and back. The transporter, used to carry mobile launcher, rocket, and spacecraft to the launch pad. It too is a study in size. The baseball diamond-sized transporter traveled at speeds up to 1/2 mile an hour, taking 10 hours to move from the assembly building to pad 39. Including its own weight, the transporter carried 9,000 tons as it crunched over a specially constructed track. The upcoming launch of Saturn Apollo will be an unmanned one. Time to test out the sophisticated rocket and spacecraft. Time to prepare 3 men for Earth orbiting missions, and finally a round trip to the moon.
This has been an Aeronautics and Space report presented by NASA, the National Aeronautics and Space Administration.
This is it. This is the predicted point of closest approach according to all trajectory calculations. And we've now passed the point of closest approach on a broad, sweeping swing past the planet, 2,480 miles above the
The
surface.
date was October 19th. NASA's Mariner spacecraft, after traveling 4 months and 217 million miles, began fulfilling its mission as it rendezvoused with the planet Venus. The Soviet Union also approached Venus, 2 spacecraft from 2 nations. Although the machines were of different design, their purpose was the same. At the Jet Propulsion Laboratory in Pasadena, the project manager for Mariner talked about the mission and some of the early results. Here's Mr. Dan Schneiderman.
This much we can say at this moment. The planet Venus is a very hot planet. The atmosphere is dense, and its primary constituent is carbon dioxide. Now, the Mariner spacecraft, by transmitting radio waves through the atmosphere, established many facts about the nature of the upper and middle atmospheres of the planet Venus. Now, though these many experiments were made and were successful, and we do have the data, there are many mysteries yet remaining about the planet Venus. For example, why the absence of nitrogen? Where is the water vapor? How does the temperature distribute itself over the surface of the planet? These mysteries will be solved by further analysis of our present data, and hopefully by more experiments of this type in the future.
Because of these missions, we know more about the planet than ever before, even though Venus, the evening star, yielded only some of its mysteries. We are as near as man can get and live to the biggest of all thermonuclear reactions, the sun. Everything we do, all the energy we have, is made possible by the sun. It is an enormous, controlled, stable thermonuclear reaction. To study the sun and its influence on the Earth, NASA has built and launched a series of orbiting solar observatories. This is the latest, OSO 4. The 599-pound spacecraft is designed in 2 sections, an upper sail-like structure which carries the pointing experiments, and a 9-sided base section called the wheel, housing for the scanning experiments, batteries, and telemetry. OSO 4 was just recently launched. Commenting on its progress, project manager Lawrence Hogarth, Goddard Space Flight Center.
OSO 4 is functioning perfectly. It's doing the job that the solar scientists once done. That job is, first of all, to find out all we can about how the sun works, and secondly, to find out what the sun in its working does to the immediate environment in which the Earth exists and moves. We are finding out, in addition to details of the sun's operation, what is happening as a result of those operations in real time just outside the atmosphere. This is the environment that the astronaut will see. It may at times be a lethal environment. Our determinations may enable us to warn the astronaut that he is approaching a time of peril.
From its vantage point of 350 miles out, the orbiting solar observatory is returning information important to both those who will travel into space as well as those who remain earthbound.
This has been an Aeronautics and Space report presented by NASA, the National Aeronautics and Space Administration.